Hi, I'm Mrs McTaggart, and in this video we're going to be looking at National 5 topic of arcs and sectors. This is lesson 1 in a series of 3. Now I've actually done these videos already, but using the formula in a different way. Based on what I've seen in some exams recently, I decided I'm going to teach it using the triple formula method. So please make sure you're watching the right video here. So let's look. So in this you're going to be looking at part circles, and you might have already seen circle before, like area and circumference, but you've probably only seen quarter circles and half circles where there's nice quick ways to get them. What we do now is we look at what's called a part circle or a sector. So this yellow bit is called the minor sector. It is the smaller sector of the circle. And if you look at the white one, it's a bit more of a Pac-Man shape. If you know what Pac-Man is, that's your major sector. And I think it's quite self-explanatory because minor means small, major means big. But you could get caught out, okay? And also, careful what angle you use. They might give you the angle of the major sector, but ask you for the minor sector. So you need to have your wits about you when you're reading the question. So a sector is a part of a circle. In this lesson, we're looking for arc. Now, arc is just a fancy word for circumference. So it's the circumference of your part circle. An arc is kind of like the curve at the top of an arch, you might want to think of. So I'm just looking for that distance. And we use lots of examples. We talk about pendulums, we talk about the length of a pizza crust, we talk about putting a ribbon around something or a border. We might even talk about how far the distance on a hand and a clock turns. So it's just remember an arc is just a fancy word for circumference. Now you should already be familiar with two formulas, which is area equals pi r squared. We're not using that one today, we're going to be using this one, C equals pi d, but I like to chat about the two and help you remember which is which. So circumference is pi times diameter. There is a song, if you want to Google it, Google their circumference song, and I think it's on the Corbett Maths YouTube, and it says a teacher singing it. It's a really annoying song, but I tell you what, it works and it stays in your head. But you need to know that when to use each one, knowing that C circumference goes with pi d and pi r squared goes with area. Tips that I use is I maybe talk about Cherry Pie Delight, so it uses those letters. So Cherry Pie Delight for your circumference, and area is pi r squared. Well, area r squared has got that the roll of the r. Also, at the end of any area question, you write cm squared. The area formula is the one with the squared. These are not given to you, and you need to memorise them. So what we do is we put these formulas into a new formula which looks like this. Now you might think, God, this looks like an awful lot. It's really not that bad. We have arc over the formula for circumference. We have area over the formula for area, and we have angle over 360 because your angle is always out of 360. And a wee bit like the sine rule, we don't use the full thing, we use the stuff we know. Majority of the questions you'll know your pi and you'll know your diameter, you'll know your angle, and you'll want to get the arc. So for today, for this lesson, because we're just looking at arc, we're not using the area part. Where this formula comes in is really terrific is when we're working backwards. Let's get into an example. So here on example 1, we are asked to find the length of the minor sector. So this is the little bit that's in yellow. Now be careful, because if I want this little bit here, I also need to use the angle for the yellow bit. That 320 is this side of the angle. So you do 360, take away 320 is 40. So my missing angle is 40. Now I'm going to use a little formula. I am not using the area and pi r squared bit, so I'm going to plug in. So I want my arc. I put arc over pi d. Now d stands for diameter, and the diameter of this circle is 7 because this is the centre, that is the radius. So the full diameter would be 14. So pi times 14. And that equals my angle of 40 degrees over 360. Then basically we want arc in its own, so this pi times 14 is in the wrong place. So this is going to cross multiply and come up here after the 40 degrees. So I then have arc equals 40 over 360 times pi times 14. And then you'll go type this into your calculator and you will get 17.104226. I always like 2 decimal places if it's not been specified. So it's safe to say that that is 17.10 centimetres to 2 decimal places. Please try and include units. Watch out for any rounding mentioned of significant figures. You can also use 3.14 instead of your pi button. I've used the pi button, but if you are using 3.14, it's always handy to maybe write that you're using 3.14 when you're doing your calculation, like change the pi. Otherwise, your marker will be thinking, where have you got these numbers from? Anyway, enough of that. Pi button anyway. Let's move on to number 2. So number 2, we have a larger sector now. We have the angle we need inside the yellow bit. We are told, this is obviously, remember this is the centre, so I'm told that my radius is 9. I'm not going to use the area part of the formula, and we're good to go. But there is a difference. This one asks for perimeter, but I'll chat about that in a minute. Let's go get this curved bit here. So we're going to do arc over pi d, so arc over pi times your diameter is double 9, so 18. Your angle is 140 over 360. Again, this pi times 18 is going to come up to the other side, cross multiply. So arc equals 140 over 360 times pi times 18. And when you type that into your calculator, you get 21.9911. So I'm happy to go to 2 decimal places and leave that as 21.99. It's a bit of a pain though sometimes when I see people rounding that and saying it's exactly 22, because it's not. Yeah, so if it can round to 2 decimal places, leave it to 2 decimal places. Technically, I could argue that it goes to 22.0, but as long as you round correctly, we won't be too harsh on you. Now, I'm not finished. I did my double underline. I forgot to read the question. It wanted perimeter. So remember in S1, etc., when you talk perimeter, it's the distance right the way around and outside of a shape. It's a fence going around your garden. It's walking right the way around Strathclyde Park, for example. So I need to add something else on here. So I've already worked out the curved part. I need to add on 9 to get to the centre and 9 to get back to where I started with. So I'm just going to leave it working at the side. I'm going to say perimeter equals 21.99 plus 9 plus 9. I don't have room to fit it in. And then if I add that on, I would get 39.99. So 39.99 centimetres for my final answer. Right, I've got one last example. As always, like things like with volume and that, they always put in it on calculator one, so I need to prepare you for that as well. So we're going to do the exact same. The only thing in this one is we're going to use pi, turn pi to 3.14 at one point. So we're not using the area part of the formula. So again, we're doing arc over pi d. Now my radius is 30, so my diameter is 60, pi times 60, equals my angle of 240 over 360. Now at this point, I'm going to simplify this fraction. In fact, you know what? I'm going to stick with what I've been doing. I'm going to rearrange it. So I'm going to write arc equals 240 over 360 times, I'm going to change my pi at this point to 3.14 times 60. Now, simplify your fraction. Well, first thing you can do is you can score off those zeros. 24 over 36. I'm hoping you spot your 12 times table. So that gives us 2/3 times 3.14 times 60. Now my top tip with any of these questions is you're not doing any division sums, so I'm just making some more space. You're not doing any long multiplication, no division sums. It should be something really simple. Basically what happens is something cancels out that fraction. We leave the 3.14 alone to the final bit. I can find 2/3 of 60. 2/3 of 60 is 60 divided by 3, 20. Double it is 40. So I'm left with 3.14 times 40. Oh, it's still long multiplication, you say, but it's really not. To multiply by 40, we're going to times by 10 first of all, and I'm going this to the side to do a little sum. So multiply by 10 gives me 31.4, and then I multiply that by 4. So we do 4 times 4 is 16, 4 ones are 4, add 1 is 5, and 4 threes are 12. So I get 125.6 centimetres for my final answer. Okay, so that makes it the end of the video. I've shown you the different scenarios you can have with this. Obviously, they sometimes put them into context as well, and maybe give you ones about Ferris wheels or clocks, and you maybe have to do a wee bit of work to get the angle first of all, but you'll see them if you do any past papers. Thanks for watching. I hope this has helped.